So this was the problem we had written for the last class related to gas mixtures. Okay. So problem എഴുതിയിട്ടുണ്ടെന്ന് വിചാരിക്കുന്നു. അത് നമ്മൾ എഴുതിയതാ ലാസ്റ്റ് ക്ലാസ്സിൽ. That is the pressure and temperature of a mixture of 4 kilogram of O2 and 6 kilogram of N2 are 4 bar and 27 degrees Celsius, which means that the volumetric analysis of a particular gas is given here. That is, it possesses 4 kilogram of oxygen and 6 kilogram of nitrogen. If it is a volumetric analysis, the volume of individual constants will be given. So here it is given as 4 kilogram and 6 kilogram. So it is clear that it is a case of gravimetric analysis. That is, the mass of the constant is given here. So the pressure and temperature are also given 4 bar and 27 degrees Celsius. So you want to find out mole fraction of each component. Mole fraction means mole fraction of oxygen means number of moles of oxygen divided by total number of moles of mixture. And also for nitrogen is number of moles of nitrogen divided by total moles of mixture. Second one is average molecular weight. There is an equation I will tell you. Third one is specific gas constant, that is R value, not R naught, it's R value. Fourth one is volume and density. Fifth one is partial pressure, partial volume. That means the volume of oxygen and volume of nitrogen and pressure of oxygen and pressure of nitrogen. So there are 5 sub questions. Therefore, it means that it will be a question, will be mark of 8 or 10, 6, 8 or 10. Okay, so it is a very important problem. It is simple, but also important. So, how we can solve it? So, please write down the given data first. Data. Given data are mass of oxygen is given here. Like mass of oxygen is mass of O2 equal to 4 kilogram. Second one is mass of nitrogen. N2 it is given as 6 kilogram. Okay. Pressure is given 4 bar. Temperature is given, that is 27 degrees Celsius, that is 27 plus 273 equal to 300 Kelvin. These are the data given. Yeah. So first one, you want to find out the mole fractions of each component. And then mole fraction. Mass of a given component divided by total moles of the mixture, right? So ഇവിടെ നിന്ന് കാണാം നമ്മൾ number of moles of each component. You want to first find out the number of moles of each component. Right? Number of moles of each component, that is to find out. So first one, number of moles of oxygen. Number of moles of oxygen is NO2. Number of moles means N. NO2 means number of moles of oxygen is given as. What was the formula for number of moles? Given mass by molecular mass, right? N equal to given mass by molecular mass, small and divided by capital. This is a very important formula. That is very important. So the equation for number of moles equal to N equal to small and divided by capital. So NO2 means MO2 divided by molecular weight. This MO2 it is given here. Mass of oxygen is given. Mass of oxygen 4 kilogram is given. Molecular weight of oxygen, we know that is 32, right? O2, 32. Oxygen 32, nitrogen 28. അറിയാം അങ്ങനത്തെ കുറച്ച് കാര്യങ്ങൾക്ക് പഠിച്ചു വെക്കണം. Then 4 by 32. Write down the value. 4 by 32 means 0.125. Second one, number of moles of nitrogen. Number of moles of nitrogen. N2. It is mass of N2 divided by molecular weight of N2. Mass is given as 6 kilogram. Molecular weight of nitrogen is 28. It means that 6 by 28 is the number of moles of nitrogen. 0.214. 0.125 and 0.2. And find out the mole fractions of each component. The question is to find out mole fraction of each component. That is mole fraction of oxygen and mole fraction of nitrogen. X is defined as the mole fraction. X is denoted, the value X is denoted as the mole fraction. Mole fraction X that is X.2 mole fraction of oxygen. What is the value of mole fraction of oxygen for the total mixture? That is mole fraction of number of moles of oxygen divided by total number of moles of mixture. Total number of moles is 0.125 plus 0.214. Total number of moles is number of moles of oxygen plus number of moles of nitrogen. And the mole fraction of oxygen means number of moles of oxygen divided by total number of moles. What is the value? Anyone?
0.368.
Very good, very good. 0.368. 368. Next will be 367 കൂടെ ഉണ്ട്. എല്ലാ decimal point എടുക്കാം. Then mole fraction of nitrogen. Xn2 is the number of moles of nitrogen. 0.214 divided by total number of moles. 0.125 plus 0.214. 0.6313, right? This number of moles of nitrogen. That is the first question. We got the value. Then second question, average molecular weight. There is an equation for average molecular weight. Okay. Average molecular weight equation. Please make it in the box. Average molecular weight equal to M equal to, if there are two constants in a mixture, we can write Ni Mi, Ni into capital Mi, Ni into capital Mi plus Nj into capital Mj divided by Ni plus Nj. That is N equal to number of moles, M equal to molecular weight. Okay. So the equation means that if there are two constants, here there are only two constants, that is oxygen and nitrogen. Okay. Question. Here in this question we have oxygen and nitrogen only. I means J means അടുത്തത്. So to average molecular weight means NiMi, number of moles of first mixture in the molecular weight of, sorry, not mixture, it's a constant. Number of moles of first constant into molecular weight of first constant plus number of moles of second constant into molecular weight of second constant, all divided by total number of moles, Ni plus Nj. So here it is oxygen and nitrogen. So we can write NO2 MO2 plus NN2 MN2 all divided by NO2 plus NN2. Molecular weight of oxygen is 32. Molecular weight of nitrogen is 28. Number of moles of oxygen is 0.125. Number of moles of nitrogen is 0.214. The all values are given. So we can directly find out the value for average molecular weight. This is the formula we can use to find out the average molecular weight of a mixture. It's a very important equation. Want to keep it in a box. It is NO2. NO2 means 0.125 into MO2 32 plus 0.214 into 28 all divided by 0.125 plus 0.214. That is the value for average molecular weight in kilogram. ഇല്ല kilogram അല്ല. It's a value. Molecular weight is a value. 32, 28 or is a value. Don't try. Mass എന്ന പോലെ molecular weight എത്താൻ പാടില്ല. Only value. Which means the value is 29 point.
47.
475. 475 is the value in textbook. കിട്ടിയ വാല്യൂ കിട്ടാതെ തെറ്റാൻ വഴിയില്ല. ഈ വാല്യൂ മാത്രമേ യൂസ് ചെയ്യുന്നുള്ളൂ. അഡീഷണൽ പെർസെൻറ്റേജ് ചെയ്യാൻ സാധ്യത. സോ വാല്യൂ 29.475 is the average molecular weight. And third question. Third question is to find out specific gas constant. Okay, specific gas constant. Specific gas constant means R value. Characteristic gas constant പറയും R. R value to find out R. You know that there is a relation between R, R naught and M. R naught equal to universal gas constant. In a text book, it is used as G. Question it is used as R bar, R naught. Everything is average molecular, universal gas constant. R naught is R നമ്മൾ യൂസ് ചെയ്യുന്നത്. Okay. R naught ആണ് യൂസ് ചെയ്യുന്നത്. R naught equal to universal gas constant 8.314. M, capital M is molecular weight. R is specific gas constant or characteristic gas constant. There is a relation between R, R bar and M. That is R naught equal to MR. That was the relation. R naught equal to MR. That is a relation. It's a very important relation. In more relation very important. That is N equal to M by M, PV equal to MRT, average molecular weight equation, and this R naught equal to MR. Here you want to find out the value of R, that is R naught by M. R equal to R naught by M. R naught value is 8.314. We know that is a constant value. M is the molecular weight of the mixture. We know the molecular weight of oxygen and molecular weight of nitrogen. So number of moles കൂട്ടുന്ന പോലെ pressure കൂട്ടുന്ന പോലെ volume കൂട്ടുന്ന പോലെ we cannot add the molecular weight of each component to get the total molecular weight of the mixture. You cannot add the values of molecular weight. Okay. അങ്ങനെ കണ്ടുപിടിക്കാൻ വേണ്ടിയാണ് ഈ ഒരു ഇക്വേഷൻ ഉള്ളത്. To find the average molecular weight of the mixture, you have an equation. You don't need to add the values of individual molecular weight to get the total molecular weight of the mixture. Only way to find out the molecular weight of the mixture is to find the average molecular weight. Okay, so you already find out the average molecular weight here, 29.475. You need to use the value here to find out the characteristic gas constant or specific gas constant, 29.475. All simple. Only here we are using only substitution. You are not using very much complex equation. You are not deriving any equation here. You are not substituting any equation to other equation. You are only using a particular equation and substituting here. So very simple question it is, the very important one. R value equal to R naught by M. 8.314 divided by 29.475. That is 0.28. R no unit ഉണ്ട് കേട്ടോ. R no unit ഉണ്ട്. That is kilojoule per kilogram Kelvin. Kilojoule per kilogram Kelvin. Here we had taken the value for R naught as 8.314, right? 8.314. 8.314 joule per kilojoule per kilogram ആയതുകൊണ്ടാണ് we had taken the value as 8.314. നമ്മൾ 8314, that is 8314 എന്നാണ് എടുത്തതെങ്കിൽ we will get the value of R as joule per kilogram Kelvin. Okay. Joule per kilogram ആയിട്ട് കിട്ടും. Any particular 0.28 പകരം we have നമ്മൾക്ക് എന്ത് കിട്ടും? 282 joule per kilogram Kelvin കിട്ടും. Joule per kilogram Kelvin. Here we are taking 8.314 kilojoule per kilogram Kelvin. So we got the value in the unit kilojoule per kilogram itself. Okay. PV equal to nRT എന്നുള്ള ഇക്വേഷനിലൊക്കെ നമ്മൾ ഇക്വേഷൻ യൂസ് ചെയ്യുമ്പോൾ when we use this particular value of 8.314 then equation PV equal to nRT equation use ചെയ്യുമ്പോൾ we are taking the value as 8314 is the whole unit in the form SI unit kilogram എന്ന് മാറ്റണം. ഈ ഇക്വേഷൻ യൂസ് ചെയ്യുമ്പോഴാണ് we want to change the value of pressure as Newton Pascal it is into 10 to the power 5 and 8.314 into 10 power 3 കിലോയിലേക്ക് മാറ്റണം, കിലോന്ന് മാറ്റണം. Here we only need to find the value in any unit. So here I have find the value of R as 0.282 kilojoule per kilogram Kelvin. Okay, that is the third question. Then fourth one, that is to find volume and density. Volume and density. Volume means total volume of the mixture. Density means total density of the mixture. If we know the individual density, we can calculate the total density as by just adding rho 1 plus rho 2 or rho 2 plus rho n2. Okay, idea matter. Here we don't know the value of density or we don't know the value of individual volume in our section. So to find out the value of volume, we only have the equation as PV equal to MRT. PV equal to MRT or PV equal to NRT. PV equal to MRT use ചെയ്യാം. NRT യൂസ് ചെയ്യുന്നത് എപ്പോഴാണ്? R naught യൂസ് ചെയ്യുമ്പോഴാണ് NRT യൂസ് ചെയ്യുന്നത്. Other case we are using only PV equal to MRT. Specific gas question വരുമ്പോൾ we are using MRT, and when NRT is using we are using R naught. PV equal to MRT. P means pressure, V means volume. Pressure is given in your problem. V want to find out. M is given, which means mass of oxygen and volume of nitrogen is given. We can add it to get the total mass. R value you already find out. R value already find. Temperature is also given in your problem. So only thing you want to find out the volume, that is MRT by P. We are using the value of gas constant in equation PV equal to MRT or PV equal to NRT. You want to use the value in joule per kilogram. That is mass. Mass means 4 kilogram per 6 kilogram. That is total 10 kilogram into R value 0.282 into 10 power 3. 10 into 0.282 into 10 power 3 into temperature in Kelvin. Temperature is 300 Kelvin. Temperature is 300 Kelvin. Pressure is 4 bar. So you want to convert into Pascal. 4 into 10 power 5. 1 bar equal to 10 raised to 5 Pascal. 1 bar equal to 10 raised to 5 Pascal. Or Newton per meter square. Pascal is Newton per meter square. So here you will get the value of volume directly in kilogram per meter cube. Sorry, in meter cube. This volume, so meter cube. 10 into 0.28 into 10 power 3 into 300 divided by PV equal to MRT. Simple use equation. NRT use ചെയ്തുകൂടെ നിങ്ങൾ ചോദിക്കാം. You don't NRT use ചെയ്തില്ലെങ്കിൽ R value you want to take the R value is R naught value. Here we are using calculated gas constant value കണ്ടുപിടിച്ചതുകൊണ്ട് PV equal to MRT. So volume is 2.115 meter cube. 2.115 meter cube. 2.115 meter cube. Volume. Volume of the mixture. Then we want to find density. Density means density equal to mass by volume. Mass by volume, or okay, you can use the equation as mass by volume, that is mass of the mixture divided by volume of the mixture, that is 10 divided by rho is mass by volume. Density equal to mass by volume. Total volume, we know the value for volume and we know the value for mass. 10 plus 6, sorry, 4 plus 6. We can use directly the value, or you can use the equation as rho equal to rho 1 plus rho 2. Rho 1 plus rho 2 means rho 1 or rho 2 equal to mass of oxygen divided by total volume. ആ വോളിയം എടുക്കേണ്ടത്. ഓക്കെ, ടോട്ടൽ വോളിയം എടുക്കേണ്ടത്, ദാറ്റ് ഈസ് 4 ഡിവൈഡഡ് ബൈ, ഈ മെത്തേഡിലാണ് ടെക്സ്റ്റ് ബുക്ക് ചെയ്തിട്ടുണ്ട്. യു ക്യാൻ യൂസ് ദിസ്. ഈ ക്വസ്റ്റൻ എടുക്കണ്ട, ഓരോന്ന് ഓരോ കണ്ടിച്ചാൽ മതി. റോ ഒ ടു മീൻസ് 4 by volume, total volume of mixture. Total volume, that is 2.115. And rho N2 is 6 by 2.115. Mass by volume. Initially, ഇങ്ങനെ കണ്ടുപിടിക്കണം. ഓക്കെ, ഡെൻസിറ്റി വേണമെങ്കിൽ ഇങ്ങനെ കണ്ടുപിടിക്കണം, ഇങ്ങനെ എടുക്കരുത്. മാസ് ബൈ വോളിയം എടുക്കണം. എൻ്റെ സെയിം ആണ് കിട്ടുന്നതെങ്കിൽ ഇങ്ങനെ എടുക്കണം. എൻ്റെ സെയിം ഇങ്ങനെയാണ് കിട്ടുക അല്ലേ? ശരിയാണ്, എൻ്റെ സെയിം ആണ് കിട്ടുക. ബോത്ത് വിൽ ബി സെയിം. Total mass is 4 plus 6 divided by 2.115. Okay, ഈ ഇക്വേഷൻ യൂസ് ചെയ്യാം. ആ ഇക്വേഷൻ യൂസ് ചെയ്തു. സിമ്പിൾ അല്ലേ? ഫസ്റ്റ് ഇക്വേഷൻ റോ ഈക്വൽ ടു മാസ് ബൈ വോളിയം ഈക്വൽ ടു 10 divided by 2.115. 4.728 kilogram per meter cube. 4.728 kilogram per meter cube. And last question, that is fifth question, is to find out partial pressures and partial volume. Partial pressures and partial volume. Partial pressures and partial volume. It is PO2, PN2, VO2, PN2. They have only our equation PV equal to MRT or PV equal to NRT. We can use equation PV equal to nRT. nRT means n R naught into T. n R naught into T. Only equation is needed to find out partial pressure and partial volume. Partial pressure we can other equations here. Volume okay, volume can be found out by another method. Initially, first you want to find out partial pressure. PV equal to nRT. It is PO2 equal to NO2 into R0 into T divided by P. PO2. Same method we can find the value of PN2. First you can find out the PO2. We know the total pressure value is 4 bar. So we can reduce this value from 4 to find the pressure of nitrogen. Dalton's law of partial pressure. PO2 equal to NO2 into R0 into T divided by V. That is NO2 means number of moles of oxygen, that is 0.125 into R0 value 8.314, right? Sorry. But as I said, when we are using this R naught value or R value, any constant value in the equation PV equal to nRT or PV equal to MRT, you want to use in the form of joule per kilogram. Then 8.314 into 10 power 3. 8.314 into 10 power 3. The temperature is 300 Kelvin. Divided by volume. Volume is 2.115. You will get the value in Pascal. You will get the value in Pascal because here we are using only a equation. In this PV equal to MRT or PV equal to nRT, we are using the value of pressure in the value of Pascal, equal to Pascal. So by using this equation, we will get the value of pressure in Pascal. Either you need to get the value in Pascal, that is any value in that particular value, if it is X value, okay, something value Pascal or Newton per meter square. Or you can change that particular value into bar. How can we convert the value into bar? That particular answer into 10 power minus 5. Right? 10 power minus 5, you will get the value in bar. That is 1 bar equal to 10 raised to 5 Pascal. So 1 Pascal is equal to 10 raised to minus 5 bar. So to convert the value into bar, you want to just multiply that value 10 power minus 3. Or equation we can use 10 power 5 in denominator. Denominator, you will get the particular value to bar. So anything, any value. If it is Pascal or it is bar, don't change the unit. Please write down the correct unit. That is the only thing you want to follow. You can use any unit, but you want to write the correct unit in the equation. Here we will get the value into Pascal. To convert it into bar, you just want to multiply that value in 10 raised per minus 5. Okay. Then like same method we can use to find. There are bar like Matthew Mansley. You know that total pressure is 4 bar, right? Total pressure is 4 bar. If we get the pressure value of oxygen in bar, okay, any bar, you will get the value as 1.474 bar, something. 1.474 bar, you will get the value here. If we get the value of PO2 in bar, you can easily find the value of nitrogen as PN2 equal to P minus PO2. Total pressure is 4 bar. That is PO2 plus PN2 is 4 bar. Okay. PO2 plus PN2 equal to 4 bar. If we find the value of PO2 in bar, you can easily find the value of PN2 by using this relation 4 bar minus PO2. If we get the value of PO2 in Newton per meter square, you can't subtract the value of the PO2 from 4 bar. That is, the two units are different. So in that case, you want to find out the value of pressure PN2 by using the same method. Again, you want to calculate the value of PN2 by using this equation. But if we convert this value into bar, we can use that particular relation. Any route you can use. If you have time, you can also calculate the PN2 value by using the same equation, that is NN2 into R naught into T divided by V. PN2. You will get the value of PN2 in Newton per meter square or Pascal. But if you convert the value of the PO2 into bar, you can use this equation. Is VO2, the value of VO2 is 1.474 bar. Therefore, PN2 can be found out by using 4 minus 1.474. That much bar. Okay, anything you can use. Do it as homework. Any method you can use. So then last one, that is partial volume. Partial volume. The partial volume can be found out by using. We have total volume here. You know that total volume, we have total volume as 2.115 meter cube, right? 2.115 meter cube. So here you want to find out the volume of oxygen and volume of nitrogen. Okay, volume of oxygen and volume of nitrogen. So total volume is 2.115 bar. So VO2 plus VN2 is total V. VO2 plus VN2 is the total V. According to Amagat's law of additive volume. Dalton's law of partial pressure is P equal to P1 plus P2. Amagat's law of partial volume is, its volumetric analysis is V total V equal to V1 plus V2. So here total V is VO2 plus VN2. So you can find any one of the value you can find, and next one can be found out by using this relation. How to find out the value of VO2? VO2 means you can find very simple, right? It is a very important relation. Mark it as a very important and pay it in a box. That is mole fraction. Mole fraction means XO2. Mole fraction of oxygen into total volume. Mole fraction only to have a total volume value here. You can find any individual value by using this relation. That is mole fraction of that particular component into total volume. XO2 into V. Also, you can find this Xn2 into V. Xn2 into V. Mole fraction, not number of moles. Okay, you don't need to use a number of moles of nitrogen or oxygen. Only to use mole fraction, not number of moles. Mole fraction. XO2. XO2 means mole fraction. NO2 means number of moles. Here XO2 is using. That is XO2 of oxygen was the value 0.3687, right? 0.3687 into total volume 2.115. You will get the volume of oxygen, partial volume in meter cube. And also by using the same relation, that is mole fraction nitrogen that was given, that is 0.6313. 0.6313 into total volume 2.115, you will get the value of VN2. Okay, the value the is 0.779 meter cube for VO2 and 1.335 meter cube for VN2. These are the two values you will get. So if we find any one of the value, that is if we find VO2 value, we can use this relation, that is VO2 plus VN2 equal to V. By using this relation, we can find the value of VN2 as total volume minus VO2. This total volume 2.115 minus 0.779, it will be 1.335. Okay. Okay. That's only for this session. So today we had completed a problem using the 3 or 4 relations. That is, first one was total number of moles equal to M by M, small letter by capital M. And we had used PV equal to nRT here, PV equal to MRT here. When we are using PV equal to nRT, we are using R value as universal gas constant R0. PV equal to nR0 into T. And when we are using PV equal to MRT, we are using specific gas constant R value. Then we had used the equation for average molecular weight. And also you had used the equation of to find the partial volume, that is mole fraction in the total volume. Okay, so I explained this problem to teach you some relations, very important relations, which can be very helpful to solve any problem in this module. We can do any problem in this module, last module. Okay.